Most kitchen cabinets do not fail from heavy use. They fail because of how they were built. A cabinet installed 2 years ago, hardware still clean, can have a box already swelling from moisture, a drawer joint quietly separating, and a particle board carcass losing screw holding capacity from the inside out. Nobody disclosed that at point of sale. Steam cycles daily in a kitchen. Humidity fluctuates from cooking and dishwashers. Every drawer opens and closes thousands of times per year. The difference between a cabinet still structurally sound at 30 years and one sagging and delaminating at 8 is not luck. It is a set of construction decisions made before that cabinet left the factory. Here are the 5 that get those decisions right and exactly what makes them last. Before the list, understand the 3 failure mechanisms that end most kitchen cabinets early. First, particle board box construction. When moisture contacts it through hardware holes or leaks, it swells and cannot be repaired. Material comparisons confirm particle board cabinets typically last 3 to 15 years under kitchen conditions, while plywood lasts 20 to 30 years. Second, drawer joint failure. Stapled rabbet joints rely on thin surface area connections that separate under years of daily loading. Third, hardware failure. Hinges rated for light use and finishes without sealed edges compound every other failure mode simultaneously. Plywood box construction is the single most important decision in any cabinet built to last. Plywood is built from alternating layers of wood, veneer bonded under pressure, with grain direction rotating between each layer. This cross-laminated structure resists warping, distributes load in all directions, and holds fasteners tightly across decades of use. Particle board cannot maintain screw holding capacity once moisture reaches the compressed wood chip core. Independent material analysis confirms even a small undersink leak causes irreversible swelling in particle board that plywood handles without structural consequence. Plywood-based cabinet boxes also carry the weight of countertops without sagging, a load that particle board boxes routinely fail under over time. Cabinets certified under the American National Standards Institute and Kitchen Cabinet Manufacturers Association performance standard known as ANSI and KCMA A161.1 must pass a shelf loading test of 15 pounds per square foot held for 7 days with no visible deflection and a wall cabinet loading test of 600 pounds. Dovetail drawer boxes paired with plywood carcasses are the combination that defines a cabinet built to a 30-year standard. A dovetail joint connects drawer sides using precision interlocking cuts that resist tensile stress mechanically rather than relying on staples or adhesive alone. Face frame construction attaches a solid hardwood frame, typically 1.5 inches wide, to the front of the cabinet box. That frame serves a documented structural function. It reinforces the box against racking, adds a second load path for door and hinge hardware, and protects the front edges of the box from the impact and moisture exposure that destroys unprotected plywood edges over time. The face frame is dadoed into the box top, bottom, and sides, creating a mechanical connection that does not rely on adhesive alone. The KCMA A161.1 standard requires a base front joint test where 250 pounds of force is applied directly to the cabinet front stiles. A face frame built from solid maple or poplar passes this test with substantial margin. Solid hardwood face frames allow doors to be hung with multiple hinge placements, provide a closing surface that does not wear or compress over time, and allow the cabinet to be refinished without replacing any structural element. The frame outlasts every finish that will ever be applied to it. Drawer slides are not a cosmetic upgrade. They are a structural component that determines whether the drawer box and its joints survive decades of loading. Side mount roller slides, the standard in volume production cabinets, apply lateral load to the sides of the drawer box on every open and close cycle. Over years of use with heavy kitchen loads, that lateral stress works at the stapled corner joints of low-quality drawer boxes and eventually separates them. Undermount slides attach beneath the drawer box, transmitting load downward through the bottom rather than sideways through the corner joints. This load path is mechanically correct for a box and joint structure. Full extension slides provide access to the full interior depth on every open cycle. Ball bearing mechanisms in quality undermount slides are rated for a minimum of 75,000 cycles by major hardware manufacturers. The KCMA standard tests drawer slides through 25,000 open and closed cycles at loaded weight before certification. Soft close mechanisms reduce impact stress on the corner joints with every closure, extending the mechanical life of the drawer box regardless of construction method. Cabinet door hinges are the highest cycle component in any kitchen. A single door in a busy kitchen opens and closes well over 3,000 times per year. Over 30 years, that is 90,000 cycles on a single hinge. The hinge mounting point in the door and the hinge cup in the cabinet side are the structural weak points. In face frame cabinets with wood screw attachments, the wood around the screw holes fatigues over years of loading. In frameless cabinets with hinges mounted directly to the box side, the same fatigue occurs at the particleboard substrate. Concealed European-style cup hinges, introduced commercially in the 1960s and refined over decades, address this failure through a mounting plate system that distributes load across a broader substrate area and allows six-way door adjustment without removing the door. That adjustability matters structurally as well as aesthetically. As a house settles and cabinet boxes shift slightly over decades, a hinge without adjustment requires that door and frame fight each other at every close. Quality cup hinges carry documented cycle ratings well above the KCMA standard minimum. Mounting them into solid plywood or hardwood rather than particleboard is the combination that sustains that rating in service. Cabinet interior finishing and back panel construction are the two details most commonly omitted at the lower end of the market, and the two that determine long-term condition for every cabinet beside or beneath a water source. An unfinished plywood interior absorbs ambient moisture with every humidity cycle. Over years of kitchen use, unfinished base cabinet surfaces under sinks develop mold and staining that accelerates with any water intrusion. A fully finished interior, whether with a catalyzed finish, a UV cured coating, or a quality melamine liner, closes the wood surface against moisture absorption and remains cleanable for the life of the cabinet. Cabinet backs are equally critical. A back panel dadoed into the cabinet sides, rather than stapled to the back edge, creates a structurally enclosed box that stays square under countertop loading and wall anchoring, and eliminates the gap where moisture and debris accumulate behind the cabinet. The KCMA certification standard requires fully enclosed cabinets with backs as a construction requirement before any testing begins. Cabinets that do not meet this construction floor are not eligible for certification. Pull the drawer box out of any cabinet before purchase. Look at the corner joints. Interlocking dovetail cuts in solid wood are the standard for a 30-year drawer. Staples in particleboard are the standard for a 10-year drawer. Ask for the box material specification in writing. Plywood versus particleboard is the single most important specification in the entire cabinet system, and it will not appear on a brochure. Check whether the cabinet line carries KCMA 6 1.1 certification. That seal confirms the cabinet passed independently verified structural, drawer, door, and finish testing. It is the only third-party performance standard for kitchen cabinets in the industry. Open and close the doors. A solid hardwood face frame with quality cup hinges closes with consistent resistance across the full swing. A door that drops or rattles at the latch point has a hinge or frame problem that compounds over years of use. Cabinets are the most expensive fixed asset in a kitchen renovation. The difference between a cabinet replaced in 8 years and one still structural at 30 is not the door style or finish color. It is the box, the drawer, the frame, and the back panel. Subscribe for the best home improvement videos.